All right, so welcome back. So we're going to continue on with our receptors and different types of receptors. So I'm just going to hide me here so you can see this image a little better. So we're going to talk about somatic sensations. So this is basically our sense of touch is really what we're talking about. So again, here you can see in this image, this is our epidermis, the dermis, and then the subcutaneous. And this gives you an idea of where some of these receptors are relative to these different layers into one another. So we have these free nerve endings. So for example, they're giving you the example of a nociceptor, so these are pain receptors. So that's fairly superficial receptor right at that epidermis level. We have what are known as Merkel discs. We'll see those in a second. Again, also at the epidermis, at the border of that epidermis dermis. We have Meissner's corpuscles, which you've seen before in the dermal papilla. Then we have what are known as Ruffini's corpuscles. Some are mid-dermis, the Pacinian, and then we'll have this hair root plexus as well. All right. So Meissner's corpuscle, right? So again, this is the one that dermal papilla. We've seen this before. So it allows us to have discriminative touch and vibration. So basically, this is going to allow you to pick something up, and you go, oh, okay. So this is, I don't know, silk. This is cotton. It allows you to discriminate between different things. However, it's going to be rapidly adapting. So this is one of the ones that, once you put clothes on, you're like, oh, okay, I'm wearing cotton. And then you forget about it. Right? So basically, it's going to generate impulses mainly at the onset of the touch, so when you first feel something. And then if it keeps touching you, it adapts rapidly, and it's not sending you information anymore. Merkel's disc, on the other hand, so that's sort of, relatively, in the same area as Meissner's corpuscle. So in this case, the dendrites are flattened. They touch the stratum basale. And there's a lot, again, these are discriminative touch. So again, these are things that are going to allow you to differentiate between, very nice cotton sheets versus cheapo cotton sheets versus satin versus silk kind of thing. So we'll see that 25% of the receptors in the hand are this type. So these will actually be even more sensitive to slight nuances than that Meissner's corpuscle. Okay. Again, we don't have to see that capsule, so it allows them to be a little bit more specific. This hair root plexus wraps around the root of the hair. So I think we talked about this when we talked about skin. So this hair root plexus is going to monitor any kind of movements on the hair. So if you have like a little bug or something that lands on your hand, it'll move the little hairs on the back of your hand. You feel that because of this hair root plexus. Okay. Then we have what's known as Ruffini's corpuscle. So this is, now we're moving away from that epidermis, we're going down into the dermal layer. So now that we're away from the surface, we're not going to be able to sense as light a touch or as discriminative a touch, okay, as these ones at the surface were able to. I think that kind of makes intuitive sense, right? So in this case, it's going to detect what's known as heavy touch. So again, you wouldn't feel like a little bug or necessarily if, how can I put this? This is not going to tell you that difference between cotton 300 count versus cotton 600 count. Okay, it's too far down to be able to be that discriminating. But it will allow you to know that, hell yeah, you're touching something, right? And this one is a slowly adapting fiber, okay? So so this is one of the ones that if something's really touching you, and I mean really touching you, not just like a shirt, but something that's heavier, you're like, all right, like you're still touching me, stop touching me, right? It's that kind of heavier touch that you realize that, as well as pressure kind of touch that you would realize. Okay, hopefully that makes sense to you. Pacinian corpuscle even further down. As we remember, this was encapsulated. So in this case, really, it's now so far down in our skin that it's not going to be able to be very helpful as far as discriminating any kind of touch. However, it's going to be our main, main pressure sensor. And it'll also pick up on high frequency vibrational sorts of things. So I don't know how much you really think about this, but you can feel vibrations, right? And the higher the frequency of vibration, at some point you won't even feel like the buzz anymore. It just feels sort of like a numb. So this kind of can feel that high frequency vibration. I guess that's all I'm trying to say. Okay. Obviously, to a certain point, at some point, you can't distinguish between the vibrations. All right. So in thermal sensations, right, we have, these are again free nerve endings, right, our thermoreceptors, and we have two different sets of receptors. We have what are known as cold receptors and warm receptors. So cold receptors are going to pick up on, basically it's their temperature range that they function at, that they'll fire at. So anything between 50 and 105 degrees Fahrenheit will activate cold receptors. Anything from 90 to 118 will activate warm receptors. And you can see there's a little bit of overlap between the two. Both will rapidly adapt at first, but then they'll continue to generate impulse at low frequency. So what that means is, and I don't know, you probably have all had this experience, where let's say you get into like a hot tub, and at first you're like, "Oi, this is hot, the water's really hot." And then you kind of like ease into it, and once you're sitting in there for a while, it's nice and comfortable. But it's not like you forget that it's hot, right? It's just comfortable. What's happening is when you first stepped into that hot tub, you're like, "Oh my God, it's so hot," because these hot, warm receptors are going, "Hey, it's hot," right? Letting you know. And then as you sat there for a while, they've adapted. But again, they're giving you the information, just not as high a frequency, so you're not interpreting it as, "Whoa, really hot." Okay? Hopefully that makes sense. So what happens? I mean, temperatures outside are routinely below 50 degrees Fahrenheit, right? I mean, even here in Arizona. So how do we feel cold when, let's say, it's 40 degrees outside, or the cold of an ice cube? How does that happen? What receptor's working there? Any guesses? If you said pain, you are right. So anything that falls below 50 degrees and below 100 and above 118 degrees, so outside the range of the cold and warm receptors, that's being picked up by the pain receptors. Okay? So I mean, think about this for a second. I don't know if you've ever had this experience again, but if you, let's say you stick your hand in a bucket of ice water, right? Your very first sensation almost burns, right? It almost like, I can't tell if that's hot or cold at first. It just hurts. That's because those pain receptors are telling you what that is. And then basically our other senses are letting us know, okay, that's ice water, right? And so your brain goes, okay, then what I'm feeling is really cold. So it puts that perception on the sensation, right? So it'd be really interesting. I mean, if we had, and the same thing with hot water, right? You get to a certain heat level, if you put your hand in it, at first you're like, it just hurts. You actually can't tell if it's hot or cold immediately, not necessarily. So it's kind of interesting how, and then our brains will interpret the information based on other sensations that are coming in, like vision, stuff like that. Like, I know it's cold because I can feel ice cubes, right? I know it's hot because I can see steam. Whatever. I think that's kind of nifty. And then pain is really interesting. So we have different types of pain. So we have what's known as fast pain and then slow pain. So fast pain is something like, all right, I hit something or I cut myself, it hurts now. That's pretty fast, right? Like you whack your shin and something like, hey, it hurts. Slow pain is something like, I don't know if you ever had an injury where, like car accidents are often things like this, where you're in the accident and it doesn't actually hurt then, or even like if you've worked out, it doesn't hurt then, but then like the next day, several hours later, all of a sudden it aches. That's a slow pain. It's taken a while for the pain to register. Okay. You can have superficial versus deep somatic pain. So this is again muscle kind of aches, muscle and skin aches. So superficial again is something that's very much on the surface, so like a light bruise, right? A deep one, like again, I don't know if you've ever really been in an accident or had an injury where and you're like, oh, this aches all the way to my bone. Like you can feel it's deep in your tissues, right? So that's the difference there. And then we have what's known as visceral pain. So again, visceral, when we talk visceral, we're talking about our internal organs. So lung, heart, intestine, stomach, all of our internal organs. So that's the visceral pain. So sometimes it can be diffuse, and what that means is that it's not just right at the site of damage, but it kind of radiates outward from that. So maybe it doesn't just hurt and right over that spot in like a small isolated area, but it spreads out over like your entire abdominal area. We'll see an image in a second. And then referred pain is basically where you'll have pain in a different body part, but it corresponds to an injury somewhere else. So what do I mean by that? So referred pain, classic referred pain, is the classic image of like a heart attack, right? You're having a heart attack, that's in your chest, but you feel the pain down the inside of your left arm. That's a referred pain. Your left arm has absolutely nothing to do with what's going on in your heart attack. It just so happens that the nerves coming in from the inside part of your left arm and your heart are going into the spinal cord at the same spot, so that the information, so your brain is getting information like, oh, there's pain coming in at this spot, and it just goes, oh, well, it hurts here, and you guys bringing pain too? Oh, all right, so it's just going to hurt everywhere. Everywhere that came from that one area or into that one area of the spinal cord, we're going to hurt there. Basically is what it is. The brain just can't necessarily tease apart exactly which neurons are bringing the pain information, so it just lumps them together. So you actually feel the pain down your left arm, even though it has nothing to do with what's going on in your heart. So here's this question of why do we feel pain? Again, really important that we do feel pain. So I want you guys, again, stop this lecture and click on this YouTube link. It's going to be a mind-blowing video. This girl is basically born without any pain receptors, and so you're going to see the struggles that she's gone through and her family's gone through to keep her healthy. All right? So I'll see you guys back when you're done watching this video. So what'd you think? Video kind of cool? Yeah, I mean, your heart really goes out to that girl. I don't exactly know where she is now. It's been a while since I've checked in on her. I know she's now through high school, or at least in high school. So she's still alive. You know, fairly successful at high school, but you know, constant struggles. All right. So this image here is showing you diffuse and referred pain. So here, for example, is the heart, right? So again, here's what we're seeing with that referred pain down that left arm. Okay. An example of like diffuse pain, so your kidneys are somewhere, you know, up in here. So instead of it just hurting right where the kidneys are, that pain is going to spread out, and it's even going to refer down to like the middle of your thigh and the outer part of your thigh into areas that have nothing to actually do with your kidneys, right? Sort of same idea with the appendix. Your appendix is sort of right here, but the pain may go over this entire area. It's a diffuse pain. You know, referred pain here for your stomach, right? So your stomach's actually here, but it'll hurt behind your shoulder blades, right? Kind of wild. So, you know, just take a look at these. I will ask you a few quiz questions on them, so just make sure you go over them, okay? How are we doing? Pretty good? All right? All right. So since this is sort of like a break point, I'm actually going to stop this video here. Let me know if you have any questions, and I will see you next time.